investigate how gases behave and what factors affect their behavior. And so we're going to look at a scenario of this tank car. So, here, let me get the light. You have this tank train, and the interior of the tank was washed out and cleaned with steam, and all the outlet valves were shut, and the tank car was sealed. All the workers went home for the evening, and when they returned, this is what they found. Does anybody know what they found? What? Maybe it exploded?
Oh, it exploded. Oh.
Does anybody else have an idea of maybe what they found when they came back? So we have, what? So maybe it, what? It compressed?
Yeah, you can see where the, or if it has anything because it froze.
Okay, so maybe we had a phase change, maybe some stuff froze inside of it. So we have the idea of maybe it exploded, maybe it compressed, and maybe we see, what? Did you say steam? Maybe you saw some steam coming off of it? So it was washed with steam. Okay, so let's see what happened. Here's what they found when they came back.
Holy. Why'd that happen?
Good question. That's what we're going to try to figure out. So I have a video of it actually happening too.
We'll never stop learning. That's
I
crazy.
just kind of just went.
Okay, so here it is.
That's crazy.
Is it because there's nothing inside of it to hold it together?
Just sit here and lost weight.
Okay, so pretty crazy event here.
How did it happen?
And so I hear you all asking, how does it happen? And I've heard you saying some ideas. So I want you to do, in the notes section of your journal, take a few minutes to brainstorm. What do you think is happening? What was happening inside or outside that made it crash? Why did it crash? How did it crash? If it helps, you might want to think of a before and after and maybe draw a picture of it. Maybe what was happening inside, outside, before, and then after.
So you know how they left it in there from after?
Yeah.
The molecules covered the whole tank, and so there was no more space for the molecules to go.
Okay. And then what?
And then like later, there was no more space for it. It just exploded.
Okay, so why would it go in?
What do you mean?
That's what you want to think. Because the tank went, it like went in.
Oh yeah.
So why would it go in?
Okay.
You're on the good thought process here.
The gravity pushed it down, so it crashed down.
Okay. What's happening? Maybe start thinking about what's happening outside. What do you think? No idea?
No idea.
We'll take a guess. What's happening inside that tanker when they steam clean it?
No idea.
Okay.
I have no.
So is there anything inside there?
No.
No? There's
It
steam.
can be. If liquid was in there. I don't know.
Okay. You don't want to guess? But you need to think about something. Try to take a guess. It doesn't have to be right at this point. What do you think, Stephanie?
I think that like either the air was being sucked out of it, like you would have a water bottle or something, how people like stuck on the water bottle and compress it. I think that's what was happening to it, or it was like sealed.
Okay, but it was sealed, right?
Yeah.
Okay. So now what I'd like you to do, does everybody have something written down? If you don't have something written down, you'll have the opportunity to continue thinking about this, because your job now is with your group. There's poster paper on the back and some markers, and I want you to work together to, first of all, share your ideas, talk about what you think is happening, why the tanker imploded, why did it crush in, and come up with a group model of what happened to the tanker. So you might want to draw a before, a middle, and an after picture. I saw a lot of you drawing those kinds of pictures. I want you to make sure to include drawing of the molecules to show what was happening inside or outside of the tanker. So you can use arrows to show movement if you want. You can use any kinds of things right now that you want to use to show, really explain what you think is happening. Okay, so what I'd like you to do is get with your groups, share your ideas with each other, then try to come up with, as a group, on an agreement for now what you think is happening. Remember, we're going to spend the next 2 weeks learning about what's happening. So now this is just your initial ideas, some guesses based on what you already know about gases.
Basically, I was just like, I don't know, like, because when
the molecules are inside the tanker with the steam. Okay,
And they close all the
it's going
valves,
fast.
right?
And
Yeah.
outside is just regular, and then
But what if it freezes and what if that makes it,
yeah,
you know,
maybe it was the
squeeze down?
cold or something.
Like it made the steam freeze or something.
Yeah, maybe it was the cold. Cause remember when the thermometer blew up?
He wasn't here.
Oh, he wasn't here. Oh, there's a thermometer here.
Yeah, that's fine.
Yeah, it exploded, right? Right. That was because it was too hot. So
That was too hot.
You're talking about when it freezes. I would have.
then it went reverse, imploded instead of exploded.
It was compressed.
Yeah, but see, it didn't explode.
It imploded. It's opposite. 'Cause that's why it was so fast. Okay, you done it. Let's just write it.
Yeah, I'm just trying to see.
I don't know how to explain it. Okay, so you know how when people have like a water bottle,
Yeah,
and when they suck on it or whatever, and like all that air comes out of it, it just compresses down immediately. I think that's kind of like what happened with the thing.
I don't get how it suck up the whole big thing. That was a big.
It is big, but the problem is it was sealed, so there's no way that the air could have been sucked out of it.
So I'm saying, like, there's no way nothing can be in it. That's what I'm saying. Like, I
Well,
don't
nothing's
think,
in it, but
yeah,
the
nothing's
steam,
in it.
I think, in the air maybe.
Busting, yeah. But like,
So, I don't know. It was like a tornado effect, hot air, cold air, mixed in.
so let's
tornado.
write our ideas down.
What do you think?
That's what I was saying. The hot air mixed with cold air.
And then especially, I don't know how you put that word, but yeah. So what? Just write our ideas down.
I guess if that's what you guys want to go with, you guys want to go with the tornado effect?
And what the tornado effect? I mean, every group's gonna have something new.
Well, I mean, because when you think about a tornado, like what they usually do is lift things and like move.
Yeah, and they don't. I don't get how.
Not really crush.
That's what I'm saying.
Well, of course stuff gets crushed, but that's usually like the
It wasn't a
aftermath.
tornado for too many people. Is right there watching it.
I'm talking about on the inside of it.
Oh. I got you. Yeah, we can say like a little mini tornado on the inside. Cause every group gonna have its own ideas, so it really don't matter.
So who wants to report this?
I reported.
So when the steam turned back to liquid, what happened? Okay. So what happens when steam turns into liquid? So if we think of our flask that it was in, what was happening when that steam got when the water vapor?
I know, I draw it like
Came off
you
of
could
it.
see the inside of it.
Where did it
Like,
go?
you guys could see it.
Okay, so it made that balloon expand, and so then what happened? How did we make the balloon unexpand?
Drawing some holes.
Maybe because it had nowhere else to go. Maybe it's stuck in there.
Okay.
Like the pressure difference, maybe or something like that.
Okay, and what happens to the stuff, the water? It's a gas, and then what happens to it when we took it off?
It turned back to water.
Okay, so maybe that has something to do with it? How would that have something to do with it? Okay, so it's a closed container, yeah, so that's good. So keep talking about these ideas because I think you're on to something important.
Spell it wrong. What were we talking about?
When we heated the balloon up with all the water and everything in it. And then like when we took it out the heat, it sucked the balloon back in. Basically that's how that is, because like, they had nowhere else to go. I just wanted to talk about like how they sucked it back in. I still can't figure that out, but I know it just didn't have anywhere else to go, so it sucked it in.
Well, I think when it was expanded, it had air pressure going out, so that's why the balloon got bigger. But then the air pressure decreased when it went back.
I think maybe it got sucked in because when it was being heated up, it got more pressure. More pressure was building up than when it was before. And then that pressure went down and it decreased a lot more than it was without pressure. Yeah, so it started sucking in.
Maybe that's what happened in the tank.
Yeah, the same thing because they
Who wants to write? You can probably
you
write
can
with
draw
it.
your picture.
Oh, okay.
On here.
For now we're just
Tank before it crushes.
and then in the middle. No,
Okay.
mine is
Tank after.
I think private.
Okay, good.
We can all take private. So in this time.
But like a whole thing is real basically saying what like about the tornado, like there's like a little mini tornado inside the tank. That causes it to just crash in instance.
So what causes this mini tornado inside?
The steam and then like the air that was already in it.
Okay.
So you made like a little mini tornado.
Okay, so you have steam inside, and what do you know about steam and its movement?
It was like rapidly.
Okay, so the molecules are moving rapidly, and then there's already some air in there. Okay, maybe, and then we know it's closed, a closed valve. And so, why do you think then it would crush after that? If you get this movement of molecules inside and air inside.
Cause you know how like a tornado is
Like it likes to move around.
Okay.
Like tornadoes, like they start in one spot and eventually they move to another one before they die out. So maybe it like was running out of space inside of the tank and was trying to get out. Maybe it finally got unsealed and the whole tank was like, no pressure.
instead of exploding.
Well, I think we can probably assume that the valve actually was sealed, so nothing was able to get in and out. It's a closed container. So let's go with that assumption that there's not movement coming in and out of anything. So it's still whatever's in here is in here. So we need to think about how does that movement of the molecules inside end up later having that tank crush. And one thing to think about is it was overnight. So think about maybe what happened overnight that could have.
So we can add anything like somebody came or
No, we want to still stay with the assumption that it was sealed. So nobody touched it. It was just there. But what happens? What do you think
Was
happened
it in
overnight?
cold weather or like hot weather?
Yeah, can we get the type of weather?
Let's just imagine it's a day like today.
Okay,
So,
then the air kind of probably
Yeah,
cooled off a little bit.
well, yeah. So, do you know how hot it was this morning when you got up?
like 41 degrees.
Okay. And then, how hot is the high temperature supposed to be today?
If I watch the news, I don't know where it's cold.
It's supposed to get up to 70 today. So
taking this
there
off
is temperature changes happening. So think about how maybe those temperature changes could affect what's happening inside of here. Okay, so let's start with the beginning here. What's happening?
In the beginning, the steam expanded and the high pressure was cooled.
Okay, so what is this high pressure? Where is the high pressure?
Like, you know how the project thing we did, like when you put in a hot water and that balloon kind of blew up from all the steam?
Okay, so can you show me that in this picture? Where is the pressure? What's the pressure doing?
It's pushing.
It's like pushing, but you can't see it.
Okay, so let's illustrate that. So it's pushing. And how is it pushing it? Like, what's going on with those?
Expanding.
It's expanding.
Gas is expanding.
It's getting hot.
Okay.
It's trying to escape.
Okay. So you might want to add that to your line. Okay, so we have pressure against the container wall here because why?
And you have lines, Carson.
Because it's hot.
Okay, and so then what happens? Oh, so it's taking up more space because it's expanding. Okay, and then what do you see? What's happening in the middle here?
It's starting to go back to water.
Okay.
Doesn't take up as much space.
Okay. Okay, so you have some liquid here, and so maybe, so you know how this has, you show me the pressure here, maybe you can try to show it here. And what are these arrows?
The pressure is making it contract
What pressure? Pressure of what?
of the steam.
The temperature.
Okay.
Decrease.
So it's putting less pressure against the walls of the container.
Yeah.
But how does that make the container then end up like this? How does it crush?
Because it's the pressure on the outside of the container. It's straight on the inside now.
Okay, interesting idea. So there's pressure in the air, and somehow that is now less than this? Oh, more than this? Yeah, you're right. Okay, so maybe you can figure out a way to show that in this picture then.
He said that it was just like regular air in the beginning.
Okay.
This is air on the outside, that's the air on the inside.
Okay.
And then when they steamed, it was like moving like crazy.
Okay.
The molecules. And then, what did he say? It was complicated.
Because this looks empty now. Is it empty?
Well, I mean, maybe it has regular air in it.
Because this is before they steam cleaned it, and so then they closed all the valves,
Oh, so
so nothing can get in or out. So there still has to be something in here. What would be in here?
Just some air. Regular.
What happened to the steam?
It went out when it exploded.
It didn't explode.
I mean, imploded because it, broke. So now there's holes all over it. So the steam went out.
So let's assume that it didn't break, that it just crushed. So like,
The steam is still there.
So the steam is still there. So how can you explain what happened?
Maybe it turned into liquid.
Why would it turn into liquid?
I forgot what I said.
Back to phase.
Okay.
You said something, right?
So it went back to liquid. So how can you show that in the picture?
Well, you can just draw some water.
Okay, go ahead. And then I want you to think about what's going on here, and then if it turns to liquid, why would it cause this crushing? Why would it crush in?
Because we learned with the heat that it expands. So if it's cold, I don't know why I think it's cold.
I guess maybe it's just a
If it was overnight, right?
It would not expand.
But it can't come out. It can't come out. It's sealed.
It probably went reverse. Instead of just like coming into like first liquid then gas, I guess it just reversed.
Okay, so you need to think about what would cause this to implode.
So if it was, for some reason, the molecules were getting smaller, they don't change size.
So what do they do?
They're pulling in the sides of the tank.
How much, remember, if I have some steam and then I have some water, which one takes up more space?
The water, no, the steam.
Okay, so think about that. You have steam here. You said it's going all quickly. What is this doing to the container?
What do you mean?
The molecules that are moving in here, how are they so they're putting pressure against the container here?
Pressure in the container.
So you might want to show me how you could show pressure inside your container. And then think about then what causes this to shrink in. Okay, so keep thinking about that. So why don't you add the pressure?
The gravity. Draw the gravity pushing down the gravity. Nice the gravity.
And then draw inside like arrows pointing in every direction. No, like out, like arrows going the other way.
Outside? Or
Like bumping out on the wall. Yeah.
So what do you think?
There's no more space for the molecules to go. So they expand all over the tank, and that's what made the explosion. But what pushed the tank down is, I think, it's gravity.
Sealed container here, so it did escape. Okay. And so then what happened?
Like maybe the steam inside the tank made the metal.
The next day. So what do you think could have happened overnight that might have?
And then it made it more easier for.
explode?
Yeah.
Break down?
So what do you think it might do? When you get it, when it gets cold, what do you think might happen?
And gravity will destroy it.
Yeah, put gravity.
The
molecules expand
gas is trying to escape the tank.
Yeah.
So like bouncing around rapidly.
Okay.
And then above it there's like gravity trying to
Pushing down.
push it on.
Okay. So what do you mean by gravity?
Gravity, like air pressing down the tank.
Okay, so there's air pressing on the tank. Is that only on the top, do you think?
Well, we just think that there's more air on the top pushing down on the top of it, since the bottom is just not a lot of air on the bottom.
So there's air pushing on the tank here, and then tell me what's going on in this picture now.
It's starting, the beginning phase is kind of being crushed in.
Okay, and so what's causing that crushing?
Pressure on the tank, and I maybe like the metal got a little weakened by the steam being so heated.
Okay.
So it probably made it more easier to compress down.
We can watch it again, but let's for now assume that nothing can get in or out. So let's say nothing can come out. What's happening inside to make it take up less space?
The molecules are breaking the other molecules because they need some space, or there's too much room inside. And then they get the other molecules and then they destroy it.
Okay. And then I want you to continue thinking about that, and then think about that they went home and then they came back the next day. So think about what maybe happened overnight that could also affect what's inside.
Molecules became other molecules, Like, these molecules went into one molecule and became bigger.
Okay, so maybe molecules combine, so they're taking up less space. But remember, if molecules combine, they become something else. So, do you think that what was inside the tanker changed?
Nothing really, because it was just inside.
Okay. So keep thinking about maybe what could have happened overnight when when they came back, they saw this. But I like seeing some of these things here. That's good. So keep it up. You're doing a good job.
Doesn't the steam come cold air or
So you think that the gas
temperature?
got cold because overnight being cold?
A glass jar, and I have some stuff in it, and then got stuck.
Do you think it's possible that the gas molecules kind of got cold, so therefore it wasn't heated, and therefore it wasn't rapidly moving around the tank, and maybe just dropped?
Yeah.
Okay, how about so
Maybe it just got sucked in. Not being heated. I don't know.
I mean, the temperature has to do something with it. I mean, it was cold, and the molecules they were moving as fast as they were moving on the daytime.
So what do you mean by suck all the air?
Like, we had a little air on the tank right here.
Where's the air?
Inside.
Inside? Is there air outside too?
Gravity.
Okay. Okay, and
Yeah,
then...
and so like all the molecules sucked all the air in, and which made the molecules bigger.
How could air get in here?
And molecules?
But remember we said it's a sealed container, so nothing can get in or out?
That's what I'm saying. Molecules,
what's-
air inside the...
Oh, so air inside is sucking somehow?
Yeah.
But what does that have to do with what you're calling gravity out here, the pressure?
Pushes down the tank.
So that's still pushing here. I don't see it here.
Oh,
But what's happening inside?
the molecules are not moving as rapidly as they were on the first day.
Okay, and so how does that allow that then to cause it to crush?
There is no more pressure.
No more pressure?
There's, I don't know,
Pressure where?
on the tank, all over the tank. Because
Okay.
over here, all the molecules are moving around, and so there's no more pressure.
Okay, so can you maybe write a note of that for yourself so when you're presenting you remember to say that part too? And that we can have phase changes, and we know there's solids, liquids, and gases, and we also know that temperature affects it. So if we go overnight, what you guys already were talking about, it could get colder.
Isn't it hard for gas to be contained? There it is. The gas didn't want to be in there. The molecules pushed outward.
So maybe
somehow.
they're pushing out here.
And
So why
they
do you-
bumped into each other too much, so they went faster, pushing out more. Maybe
But that would cause an explosion, right?
Yeah, but only
And
the
we're
middle
getting
collapse.
an implosion.
Yeah, because the middle collapse and the sides really didn't collapse.
Okay, so only the middle collapse. So if you have like a water bottle or something, how do you get it to collapse?
easily.
How?
You just take all the air out of it.
Okay. Or how else could you get it to collapse? I have a can in front of me, or what can I do to make it crush? Yeah, you stomp on it. So what are you doing when you stomp?
So it's like an air feed. Hulk angry.
So
So
maybe there's something going on outside that's making it get smaller, too.
It's like basically an invisible foot, like an invisible foot out of molecules.
trying to get in it.
Yeah, just stumped. They just stumped on it and just.
You're good.
Okay, so let's take all these ideas. So you told me you have molecules moving around. You also told me they're expanding and they're putting pressure around the outside of the thing. So maybe you could draw some of those, something to show me that it's putting pressure against the walls of the container.
You can make another one, or you just.
So it's 70 degrees in the middle of the day, and then maybe 30 degrees overnight.
I think
How could that affect what's going on
Because by
inside
the
the
weather
tank?
changing, the molecules like.
Michael, turn it off.
By the weather changing, the molecules. I don't know.
Maybe the steam cooled down.
Okay, so if the steam cooled down, what would happen to it?
It wouldn't move as fast.
Okay.
It would start to slow down, maybe go back into a liquid form.
Okay, and so maybe if that happened in there, how is that different than what you showed me here now?
Because it got water in it now.
Okay, so why don't you draw that?
Here. Can you use the blue pen?
So you have water in there now. And so why would water being in the bottom of this tank make it?
Cause you know how like steam is, like when you have steam, like or something like basically it turns into like a little liquid. So I think all that steam molecule after it exploded it turns into like a little liquid at the bottom.
Okay, so we have the liquid here on the bottom. And so how is the liquid here on the bottom different than what you showed me here?
Because the molecules are moving slower.
Okay.
It's a different phase.
Okay. And so how could that allow the can to get crushed?
The whole point is project lab.
Yeah.
See how it get crushed.
So how could it get crushed? Take a guess here.
So like, hey, I'm taking a funny guess. Like,
Okay.
the molecules, like it transforms into a molecule foot.
Okay.
MF, right? So then it just like it was so big and so powerful because of all of the steam and stuff, and then it just stumps, and then just all the pressure came.
Okay, so let's say I take this imaginary foot and I try to stomp it on here, and now I try to stomp it on the one with water in it. Which one would crush more?
The one with water in it.
Why?
Water.
Because the water's not moving outward. The water's just kind of, it's not moving as fast. It's not trying to really get out. It's just there.
Okay, so I think that's a pretty good explanation, but let's think about what this imaginary big stomping foot is. What is the foot? So it's air.
It's air.
Okay, so show me that here, show me that here, and then you'll be ready to present.
You know how to draw a foot?
Yeah, like the foot, like this. Bam, bam, bam.